All right, Regions Review number 11. So first one we're going to deal with here is an area question, and this specifically is an area of a shaded region question. So this is a unique one, but I thought it was a good one to utilize because it has a lot of different pieces going on in it. So we're looking for the area of the shaded region, or the gray area here. So first off, it's an irregular shape, so we got to break this shape up into pieces to just find the area in general. So let's say to find the area of, let's do this as, let's call it the blue section. Right, so that area, what this is really is the countertop, is going to equal, and we're going to break this up. We're going to break it up into one big rectangle here and a second big rectangle here. So this first one, right, we've got the fact that it's 8 feet long and 2 feet wide. So we've got the area of, call it rectangle 1. And then we're going to add the area of rectangle 2, which we're going to call this green one here. Right? Now it's got a width of 2, but the 5 is all of this. So we have to recognize that this over here is the same as this over here, which is 2. So that makes this section here 3. So we got a 2 by 3 section there. And then we also have to remove the area of the sink, right? This section here. Right? And that's a little trickier only because they gave it in terms of inches and everything else is in terms of feet. So we have to just be careful. So let's, I'm going to scroll down here and make a little space here. Let's do each of these things individually. You know what, just for space here, let's put this information down here. And let's do the work up here. So area of the first rectangle, right? We said that's a 2 by 8, and that's just length times width. So that's just 16. The area of rectangle 2, again, length times width, is a 2 by 3. And that's 6. And now the area of the sink, again, we have to convert. So if we convert this, right, there's 12 inches in a foot, right? So 12 inches equals 1 foot. So if we take the 12 inches and we do 18 inches divided by 12, I'm going to get 1.5 feet. And if I take the 21 and I divide by 12, I'm going to get that's 7/4 or 1.75 feet. Again, if you want to do it in fractions, you can do it in fractions too. Not a problem. So again, we're going to have a length times width here also of 1.5 times 1.75. And in that scenario, what does that end up being? 2.625 or 2 5/8. All right, so now we're going to take each one of those answers and we're going to go plug them in. So we've got 16 plus 6, and we're going to minus this 2.625. And if I do that, I end up with what? That's 22 minus 2.625, which is just 19.375. And we're asked to round here, so that's approximately 19 feet in this case. Giving me answer choice. Oh, there it is, D. Right past it. All right, so there you go. There's one type of area question. Again, area questions can vary, but this was a good one, the shaded region. Again, irregular shapes. You have to remove the piece within it. So there's a lot of moving parts for this one, but it's a good example of a little bit of everything that's going on there. All right. Another area question that's becoming, again, more frequent is the area of a figure, and they give you the coordinates. So let's plot this to start. We've got A is -2, -1. That's A. 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -1 is here, which is B, and then 4, 4 is here, which is C. So again, if I take my drawing tool here, and we can connect them, That's what my figure looks like. Now, in this case, again, if you wanted to, you can just use the traditional 1/2 base times height. And it's not terrible because A and B is a nice horizontal line. So we could go from C and we could figure out what that height is. And this would be perpendicular, which is a base and a height. So that's not terrible. But what happens if this is, just hypothetically speaking for a second, let's just pretend that maybe this figure was rotated. What if it was like that, right? And it's not as easy to just calculate that height there, right? That would be difficult. So we need to kind of have a method that can work for everything. And the good thing is we do. It's called the shoelace method, if you remember. And we can just take them. So I like this because it does not matter what type of shape it is. Any shape will work. So again, all we have to do is start with one of the points. I'm going to start with A here, -2, -1. All right, and we're just going to go in order. So I'm going to go, in this case, counterclockwise. So 10, -1, 4, 4. And I want to go all the way around the figure. So I want to start here, go here, then back to here. So that means I need to put another -2, -1, so that I end up back to where I started, right? And once I have this, now we can actually perform our process, and that is diagonal multiplication. So we're going to diagonally multiply each set of coordinates. So -1 times 10, -10. -1 times 4, -4. 4 times -2, -8. And I'm going to add these all up. So if I add that all up, I end up with -22. I'm going to do the same thing on the right side. So -1 times -2 is just 2. I end up with 4 times 10 is 40. And -1 times 4 is -4. So again, if I add up this whole section here, was it end up being 38 for that one. And then to find our area, all we got to remember is it's the large number minus the small number divided by 2. And in this case, the large number is 38. That's the positive. We're subtracting a -22, the small number. And then we're going to take that and we're going to just divide the whole thing by 2. And when we do this, let me make this the same color here. There we go. And when we do this, that ends up with what? Minus and minus ends up being plus. So let's make that plus. And we end up with 60 over 2. And that's just 30 units squared. We don't know what they are, so just area equals 30 units squared. So again, that shoelace method will work no matter what type of polygon you have. As long as it's a polygon, you could do it. All right, next question. Another question that seems to be frequently coming up is secant line questions. This one happens to be one of a secant line here and a tangent line here. Right? So again, you have to be careful with these questions because they could be asking you for angles or for segments. So two different situations. In this particular one, they are asking me to find the measure of angle P. So angle P is out here, and that's my exterior angle. So exterior angle equals, in this case, big arc minus little arc, all divided by 2. So in this case, that is, as we just said, angle P is going to equal my big arc. Now, again, if I trace back here, like we did before, right, we trace all the way back here, I'm at E, and that will intersect back here at Z. So that's my big arc, right? Now, they didn't give me that information directly, so I got to go figure out what that is. And we look at here, and they tell me that LZ, which is this angle here, which is our, arc here is 56, and that's our small or our little arc. So I can figure this out because this is a diameter, right? From L to E is a diameter, so that means from E all the way to L there, right? That makes that a diameter. So 180 minus the 56 is going to get me this large arc, which is 124. So now that we know that the big arc is 124, we're going to subtract the small arc, which they told us was 56. And again, based on our formula here, we're going to divide that whole subtraction by 2. So let's actually do the math now. So 124 minus 56 is 68. Divide that by 2. So that makes angle P equal 34 degrees. So again, this is not a bad question overall. It's a pretty straightforward exterior angle question, but it's something that's been showing up more and more. Again, this can vary though, because they can, first off, they can give you the one of the arcs, and the line does not go through the diameter. So maybe they give you the angle and they ask you to find one of the arcs. So there's a lot of variations. And the other thing is you got to be careful at is that this could have been an entirely different question dealing with the secant line, because they could have asked you to find the segment and given you like the lengths of these things. Like maybe they told you the length of this and length of that and said to go find me this. So again, there's a lot of different alterations. We've done all of them. You just got to be careful when you're looking at it. All right, last but not least, another question that has been showing up more and more is we always have volume questions, but these are some volume of hemispheres and cones and stuff like that, or portions of them have been showing up. So in this case, we got the volume of a hemisphere, which is half of a sphere. So in this case, we're going to do this 1/2 of 4/3 pi r cubed, because this is the sphere's formula. Now, I personally would simplify this to start, or if you can memorize the fact that all of this is just 2/3, then you just, all you know that it's 2/3 pi r cubed is the hemisphere formula. But again, worst case scenario, you just multiply by 1/2 of the sphere. All right, so let's go plug this stuff in. So the nice thing is I only got to plug in one thing, and that is my R value. But they don't give me R. They give me the diameter. So they're saying the diameter equals 12.6. We know that the radius is half of that. So 12.6 divided by 2 is going to equal 6.3. So now we can go back here and say 2/3 pi times 6.3 raised to the 3rd power. And again, we have a calculator, so this isn't terrible, to do. 6.3, just in case you don't want to plug it all in one shot. This ends up being 250.047 when I plug that into the calculator. I can take that number and multiply it by pi. By 2/3, and that would be 166.698 pi. So now maybe the question says in terms of pi, right? That's right here. This is in terms of pi. Remember that. So if it says in terms of pi, you're done. But in this particular example, it says to the nearest 10th. So we're going to actually multiply by pi. So when I did that, I got 523.69721. And if I round that, that's going to be 523.7 cubic centimeters. So that's my answer for my volume. Now, just to take this one step further, because this isn't a terrible question, it's pretty straightforward, but maybe we could include some density in here. So I'm going to actually add on to this question and say, let's pretend like if asked to find density. All right? So in order to do that, we have to remember that our formula is density equals mass over volume. So in this example, we could have found the volume like we just did, and perhaps they gave us the mass. So let's make a question up. Say, what is the density of, let's say, this marble hemisphere that weighs, let's say 1,500 pounds. That's something big, right? So density equals mass over volume. So the mass in this case is my 1,500 pounds. And we're going to divide that by our volume that we could have calculated as 523.7 cubic centimeters. And in this case, all I have to do is physically divide. And there's no way I'm doing that in my head. So let's take that number. So 1,500 divided by 523.7. I'm getting an answer of 2.8642 blah, 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 blah. So let's pretend the density, we'll do the same rounding here, is approximately 2.9. And this would be pounds per cubic centimeter for that one. So there's again an alternative question that they could have asked, or maybe that was the question in general and you still had to find the volume first in order for you to even calculate what the density was. So I just thought it would be a good question to add on here because these density questions, they do pop up. So being able to solve them, and again, maybe they gave you the density and you had to find the volume and then calculate what the mass was. Again, you could manipulate this little formula here, right? You can manipulate this into mass, volume, or density as the in either version, whatever necessary. All right? So hopefully that's helpful. Again, utilizing these as good review practice questions for your regions.